Hello students, so today we are going to start with exercise 1.4 from chapter number 1. In the first question here we have to, without actually performing the long division, we have to check that the following rational numbers will have a terminating decimal expansion or non-terminating repeating decimal expansion. So to do that, let's understand it first. So how to check that a rational number has terminating or non-terminating repeating decimals without actually doing long division? So what we will do first, we will simplify the given rational number. It means we have to convert into the lowest form. If there are any common factors in the numerator and denominator, then cancel it out first. Let's suppose if it's given like 12 over 20, we can say both of them has 4 as a common factor. So we can write it as 3 times 4 and 5 times 4. Here 4 will be cancelled out, so the lowest simplified form is 3 by 5. Now second step is to, now after simplifying the given rational number, we have to prime factorize the number in the denominator. It means we have to prime factorize this 5. Now then we have to check the after prime factorizing the denominator, if it is in the form of 2 raised to the power n or 5 raised to the power n, or it is in the form of 2 raised to the power n times 5 raised to the power m. They can have different powers, they can have same powers. If its denominator is in the form of any of these three forms, then and only then it will have terminating decimal expansion. Now we will start with the question. In this first one, there is no common factor, as 13 is a prime number, so there is no common factor. So it's already the simplified form, as you all observe that we have already done the prime factorization. So we can write denominator in the form of 5 raised to the power 1, 2, 3, 4, 5. So denominator in the form of 5 raised to the power 5. So it means it will have terminating decimal expansion. As denominator is in the form of 5 raised to the power n, it will have terminating decimal expansion. Now in the second part, it's 17 by 8. 17 is a prime number, so we cannot factorize it. So there is no common factor in 17 and 8. So now we have prime factorized 8. So we can write this as 17 by 2 raised to the power 3. So we have denominator again in the form of 2 raised to the power n. So it implies it will have terminating decimal. Terminating decimal expansion. Now in the third one, the number given is 64 by 445. Again it's already the simplified form. There is no common factor in between numerator and denominator. Now we have prime factorized 455, so we can write denominator as 5 times 7 times 13. As you observe here, we have 7 and 13 also in the denominator, so it will have non-terminating repeating decimal expansion. As you can observe, it has 7 and 13 also in the denominator. Now we'll continue with the next question. In the next one, it's 15 by 600. So we can write as we can write it as, in the simplified form, we will get it as 3 by 320, as they both have 5 as a common factor in the numerator and denominator. So we have cancelled them with 5, so we'll get 3 by 320. So now we have to prime factorize the denominator, that is 320. We will start with 2. It will be 160, then again 2, it will be 80. Again 2, it will be 40, then 2, 20, 2, 10, 2, 5 and 5, 1. So we can write denominator in the form of 1, 2, 3, 4, 5, 6. So it will be 2 raised to power 6 times 5 raised to the power 1. So our denominator is in the form of 2 raised to the power n times 5 raised to the power m. So it will have terminating decimal expansion. Now in the next one, in the fifth one, its number is 229 by 343. It's already in the simplified form, so we have to find the prime factor which is already there. So we can write denominator as 7 raised to the power 3. Here denominator is not in the form of 2 raised to the power n or times 5 raised to the power m. So it will have non-terminating repeating decimal. Now in the sixth one, as you observe here, denominator is already given in the prime factored form. The given number is 23 by 2 raised to the power 3 times 5 raised to the power 2. Numerator is already a prime number, so it's already in simplified form, and denominator is given in the prime factored form, and it's in the form of 2 raised to the power n times 5 raised to the power m. So it means it will have a terminating decimal expansion. Now in the seventh one, it's also given in the prime, denominator is already given in the prime factored form, but as you observe in the denominator we have 7 raised to the power 5 also. So it means, yes, so it means it will be a non-terminating and repeating, it will have non-terminating and repeating decimal expansion. In the next one, it's given 6 by 15. If we prime factor the numerator, it will be 2 times 3. Denominator will be 3 times 5. We can cancel out 3 here. So it will be 2 by 5, and 5 is so it's already in the lowest form, and so the decimal expansion is in the form of 5 raised to the power n. So it will have terminating decimal expansion. Okay, now in the next one, the given number is 30 by 50. If you observe, we can write 30 as 3 times 10 and 50 as 5 times 10. So in the lowest form it will be, in the simplified form it will be 3 by 5, and denominator is in the form of 5 raised to the power n, so it will also be a terminating decimal number. Now in the next one, this is 77 by 210. Let's first simplify this. We can write 77 as 7 times 11, 210 as it will be 7 times 3 is 21 times 5 times 2. So here 7 will be cancelled out. We are left with 11 by 3 into 5 into 2. Here denominator it also has 3 in the denominator, so it will be a non-terminating repeating decimal expansion. Okay, so now we will do question number 2. In this question it says write down the decimal expansion of those rational numbers in question number 1 above which have terminating decimal expansions. So in the from the question number 1, which the numbers which had terminating decimal expansion, we have to write a decimal number for it. So for the first one, it's 13 by 3125. As we have already prime factorized it, we can write it in the form of 13 by 5 raised to the power 5. Here we are not using long division because it will be too complicated. So what we are doing, we will be using this prime factored form, and we will just multiply numerator and denominator with 2 raised to the power 5. So it will be 13 times 2 raised to the power 5 is 32, and if you see in the denominator we will get 5 times 2 raised to the power 5. So when we simplify this, 13 times 32 is 416, and 5 times 2 is 10. 10 raised to the power 5, it will have 5 zeros, 1, 2, 3, 4, 5. So we can write it as 416. It has 5 zeros. So we will do like this: 1, 2, 3, 4, 5, and then put a decimal. So it will be 0.00416. Now for the second, it's the given number is 17 by 8. Here it's a small number, so either we can use long division or we can use the method that we have used in the first part. We will be using the same approach. So we'll write 17 by, it will be 2 raised to the power 3. It has, so we'll multiply it with 5 raised to the power 3 by 5 raised to the power 3. Once we simplify it, we will get, it will be equal to 2125 by 1000. So we can write it as 2125, and it has 3 zeros. So 1, 2, 3 will place a decimal. So it will be 2.125. So the next number is 15 by 1600, and we have got in the lowest form it was 3 by 320, and it's the prime factor from the denominator is 2 raised to the power 6 times 5 raised to the power 1. We have to make the power of 2 and 5 same, so we will multiply and divide with 5 raised to the power 5 raised to the power 5 and by 5 raised to the power 5. Once we simplify it, we will get 9375 by 10 raised to the power 6, and it will be 0.009375. For the next one, it's already in the prime factored form. What we will do, make the power of 2 and 5 same. So it's 2 with the power 3, 5 with the power 2. We will multiply numerator and denominator with 5. 23 times 5 is 5 times 3 is 15. 5 times 2 is 10, 11, and it will be 10 raised to the power 3. So it will be 0.115. Next is 6 by 15. In the lowest form, it will be 2 by 5. We can multiply now numerator and denominator by 2. So it will be 4 by 10, and in the decimal form it will be 0.4. Next is 35 by 50. We can write it as 7 by 10. So it will be 0.7. Okay, so now we will move to next question. In the next question, it says the following real numbers have decimal expansion. There are 3 real numbers given in the decimal expansion form. So in each case, decide whether they are rational or not. We have to check if they are rational numbers or not, and if they are rational and of the form p by q, what can you say about the prime factors of q? Let's first understand about it. So if it's a rational number, then it will have either terminating decimal number or non-terminating repeating decimal number. So if it's a rational number, it means we can write it in the form of p by q, and its decimal number can be either terminating or non-terminating repeating decimal. If it is terminating decimal number, then denominator can be in the form of 2 with the power n times 5 with the power m. And if it's non-terminating and repeating decimal number, let's suppose if it's like 1.2323 and so on. As you observe here, it's non-terminating, but a pattern is being repeated here, but here denominator will not be in the form of 2 with the power n times 5 with the power m. And for if the decimal expansion is non-terminating and non-repeating, it means if it's like 1.01000010003, here you observe it's non-terminating and there is no pattern here, so it will not be a rational number. It is an irrational number, and we cannot write irrational number in the form of p by q. Okay, now we'll go back to the question. Here the first one is in the first part. If you observe this number, it is a terminating decimal number. You can count the number of digits after decimal, so it will be in a rational number, and we can write in the form of p by q, and its denominator is in the form of, its q will be of form of 2 raised to the power n times 5 raised to the power m. Here in the next number, if you observe here, it's a non-terminating. Also there is no pattern, so it means it is a irrational number. And in the third one, as you see, there is a bar above this number. It means this is a non-terminating number, and these number will repeat with a given with a pattern. So it means it's a non-terminating and repeating decimal number. So it means it's a rational number. And its denominator is not of the form 2 raised to the power n times 5 raised to the power m. I hope this video was helpful to you, and don't forget to like and share. Thank you.